Okay, 1.5. So we're talking about volumes of right pyramids and right cones. So we've talked about surface area up to this point, right? And now we're talking about volume. So it is, volume is the space that a three-dimensional object takes up in space. Okay, so Chromebooks away now, please. I see some Chromebooks up. Just put those right away. You do not need those out right now. Taking notes here, focusing right up here. So volume, there's actually a difference between volume and capacity. And so it's slight, but I thought I'd write it up here just because we'll talk about those two different words. They're slightly different, mostly the same, but slightly different. So the volume is simply the space that any object takes up in space. So right now, this remote for the projector is taking up a certain amount of space. It is displacing, air. If it was all sealed and there was no air inside, it would. If I brought it into the room, exactly this volume of air would have to leave the room. Okay, it's taking up space. Or if you plunked it in, the bathtub or something, and you held it underwater, the water level would rise a bit because this is taking up space that once was occupied by water. So that's the volume of something. So the bigger something is, the more space it will take up. Okay. The capacity. So capacity is slightly different term. What it means is the ability for a container to hold a certain amount of material. So they're slightly different. So capacity is the amount of material that a container holds. So if I were to, take a cup, so here's my mug. If I took this mug and I filled it up, I would have a measurable capacity. There would be a maximum amount of material that I could put inside this cup. The space, the volume of this actual cup would be much different because the volume of this actual cup, because it's carved out inside and has like empty space inside. I'm just talking about the material, like the actual cup itself. How much space does this cup take up as it floats in space? So how much it can hold is sometimes different than what the space that the container actually takes up. So we have to be careful about that because we are going to be talking about hollow things, right? So we talk about hollow things and we have to be careful. Is there a volume? Well, there might be a capacity. Volume might be different. So just be careful about those two. So volume is oftentimes in meters cubed or centimeters cubed. It's in cubic units. Capacity is usually measured in other capacity units like liters or gallons, sometimes cubic centimeters. Did you know, I don't know if you knew this, but a cubic centimeter, so 1 centimeter cubed, 1 centimeter by 1 centimeter by 1 centimeter, is equal to 1 milliliter. Did you know that? 1 milliliter. Yeah. So there's 1,000 milliliters in a liter. Okay, so you have a big liter of Coke or whatever. There's 1,000 little milliliters in there. And each milliliter is 1 centimeter by 1 centimeter by 1 centimeter in volume. So that's not a lot of grade 10 students know that. So that will come in handy maybe a little bit later. All right, let's talk about volumes of right prisms and pyramids. So as you remember, hopefully you remember this, that when I talk about a right prism, a prism means that, first of all, that the base area and the top area are exactly the same. That's a prism. A pyramid is when we have a base area that can be any kind of shape, but all the sides come up to a point, right? And not a top that's the same as the base. So a prism has top and bottom, or end and end that are exactly the same. A pyramid has one end that's a certain shape and one end that's a point, or the bottom is a shape and the top is a point. And then of course the right part here, right? You remember that if we draw a line from the middle of the top down to the middle of the base, and then draw a line from that point to anywhere on the side, it forms a 90-degree angle. Same here, 90-degree angle, making it a right pyramid. Okay? Because it is possible to have, something that looks like this, and it's possible that, it's shifted over a bit, right? And so if it's shifted over a bit, these angles are all, they're not 90 degrees, right? So this is not a 90-degree angle. It's something either less or greater, whatever. So if it's like, if the bottom and the top are exactly right on top of each other and they form a 90 degree like this, then it's a right. And if it's shifted a bit, it's not a right. And of course, without this 90-degree angle, it's tough for us to find a slant height on a pyramid. So if it's not right, it's quite a bit more complicated to find the slant height. So that's why in grade 10 we're dealing with just right pyramids and right prisms. There is a way, which not this course, but next pre-cal 20, I think it is, pre-calculus 20, your next course that you'll take. We'll talk about how to find, you know, a third side to a triangle that's not a right triangle, because it takes some special math, but you'll get there, and I'll teach you that. All right, so the volume of a prism is pretty straightforward, and you should all know this, because if you had something simple like a square base, let's say, a square base, and there was a square prism, so you'd have the same top as the bottom. This is a bad drawing, sorry. But if you could picture that, then it's the area of the base times the height. That's it. It's like you take the area of the bottom part and you like stack them all up, and then that gives you your volume. So it's the area of the base times the height. Or length times width times height. You remember that one? So length times width is the area of the base, and then the height is the height. So volume, length times width times height, means this is the area of the base if the base was a square or a rectangle. So that's where this kind of comes from. The volume of any prism is the area of the base times the height, because the base is not always going to be a rectangle or a square anymore. It's going to be a weird shape, like a pentagon or a hexagon or something like that, triangle even. So yeah, length times width times height works for boxes, square bottom, rectangular bottom, good. But if it's not, then just think of it as the area of the base times the height. Now, this one here is the formula. I will tell it to you, and then I'm going to show you this little YouTube video, which will demonstrate that this is true, which I think is pretty cool. So the volume of a right pyramid is the area of the base times the overall height, but then it's divided by 3, or times 1/3, okay? And I'm going to just load up this video and show you in a second. Okay, so this will demonstrate, what this guy has here is, he has a pyramid-shaped container, and it's full of water. This is a prism-shaped container that's empty. And notice, well, you'll have to notice here that the actual top, or the base of the pyramid, is the same as the top or the base of the prism, okay? So we literally have a base, one is a prism, and one is a pyramid going to a top. And so this is full of water. So let's see what happens here as we play this video. Okay, full of water, he's dumping it in. Okay, awesome. There you go, see, same base. Now, it's filling up a second one. Right up to the top. Pouring that in. Whew, not quite. That's number 2. This is number 3, very tippy top, full, and look at that. So exactly 3 of these, the volumes of this pyramid, goes into one prism with the same size base. So that's where we get our formula from there. All right, so there's a demonstration that this is true. So let's do a little example here. So here's example 1. If you write this down into your notebook, take a moment to sketch that diagram. And again, remember, sketching a pyramid diagram will show you step by step how to do it. So we're calculating the volume of this right square pyramid, which means that we have a 90 degree from the tip to the base, the middle of the base there. And the base is a square, and the pyramid means we come up to a little tippy top point. So in drawing this, if you're wondering how to draw this, I would suggest doing this, do a line, and then do a slanted line, like that. That's going to be a little bit shorter because of how you're viewing this three-dimensional figure. Even though they're the same, this is 4 and this is 4, usually this side one's a bit shorter. And then I would go up from sort of like in the middle here, go straight up, and then put a point. Do that next. Then, from the point, draw a straight solid line to each of the 3 corners of the base that you can see. All right? And there you have a pyramid that is a solid looking pyramid that you can't see through. And now, to finish this off, you would go dashed lines, because these represent edges behind the front surface that you can't see. And so there's the back side, here's the back, and here's a dotted 4th line to this corner. Okay? So that's an easy way to draw a three-dimensional pyramid in math. Do it that way. Also, because you can see this face, this could be a solid line. So anything that you can see from this perspective can be a solid line. Anything that would be behind that you can't see would be a dashed line. And that holds true for every shape. Okay, don't write this, but look at this. This is how I would do in calculus. We have to do a lot of box stuff. So this is what I do. Okay, and this one has an open top. And it has an open top, and it has, I can see this back edge, can't I? If it's an open box, I can see this part of this edge, but I can't see this one. So this is what I do. You see? Anything that you can't see from this perspective is dashed, or a line, and anything that you can see is dotted. Now, that's just an example. Now, if you're really good at like this spatial stuff, you can actually view this box from the underside, as well as from the top side. So ready to throw your brain into a tizzy? This is the open top part. Now, if you look at it from the underside, this right here is the bottom. That's the bottom of the box, and you are underneath it, looking at the bottom of the box. Can you see that now? No. The dashed lines are kind of like not dashed anymore because you're actually seeing this is the bottom of the this is the bottom right here. That's the bottom, and someone is over here pouring stuff into the top. And it's going in like this, you see? Hey, is that crazy or what? Okay, so if you can, yeah, this is like some spatial awareness. So if you can see things from different perspectives in your mind, if you can like imagine a box that is rotated and things like that, like if this is something that you can kind of do in your mind, this will actually really help you in math. And you can kind of train your brain for this too a little bit. But anyways, that's just a bit of a fun aside. Okay, all right, sorry. Some of you were really excited about that, it's good. You saw it. Yeah, right. Huh? Then you lost it? Oh, too bad. Okay, keep working on it. All right, so calculate the volume. Now, with this one, it's not a simple, straightforward question because if you remember, you need to find the area of the bottom. Check, that's easy. But you need to multiply that by the height of the pyramid, which we are not given. And then you need to divide by 3. So I am going to now find the slant height. Who can just shout out now? How do we find this? Sorry, I'm finding the overall height. How do we find that now? Yeah, Pythagoras. Yeah, I was looking for someone to say Pythagoras. Very good. So I actually have a right triangle. Okay, here's 6. What is this bottom length? I'm not given it, but what is this bottom part of this triangle? Yeah, 2. Very good. It's half of 4. You see? That's great. This is half of 4 is 2, so this side is 2. And I don't know this h, so I'm going to find the h here. So remember, these two are you add the squares of the legs of the right triangle. So it's going to be h squared plus 2 squared equals the square of the hypotenuse. So h squared plus 4 equals 36. And again, you worked with solving equations in grade 9, so hopefully you're decent at this. I want to get h all by itself, so I got to get rid of this 4 by doing the opposite operation there. So I'm going to subtract 4 from both sides. And again, I'm watching some of you do your homework, and I'm seeing your homework. I really, really want you to work down like this, okay? Do not work side to side. Don't do half of the calculations here and then other half over here and then try and bring them together. Try and do your work just like I'm demonstrating for you, okay? At least give this a try, because I can tell you that 99% of all of my math students in grade 12 and in calculus, they all do it like this, because this helps keep everything in order. So even this, like show your operations, like do a little bit of that, right? And then rewrite things that you don't touch. And also keep your equal signs kind of roughly, vertical, okay? Keep them, and then so now what I'm going to do is I'm going to show, that I'm going to take the square root of both sides. And then h now is by itself.
36.
Oh, sorry, this would be 32. Sorry. Too busy talking. Thank you. So the squared is gone, and this is square root of 32. And that you can write as a decimal. No problem. 32. So let's try that. Square root 32. Okay, good. Is everything making sense here then? I would go to at least 2 decimal places before the end of the question. Keep as many decimal places as you can. So 5.66 is as much as you want to round that. Okay, so that's the height. I need that height, and I'm going to use as many decimal places on my calculator as possible, and I'll round at the end. But so now, my volume formula for a pyramid, right, is 1/3 the area of the base times the height. And that's just one way of representing all that. The A sub B was a subscript B, that's area of the base. You could also write it like this: area of the base times the height divided by 3, if you like that better. I'm fine with that. It means the same thing. So I'm going to go, area of the base is going to be 4 squared, right? Times the height, which is determined to be 5.66. Okay, so I'm going to use the whole decimal because I've got it on my calculator, so I'm going to start with this number right here. I'm going to multiply by 16, so times 16, and then I'm going to divide by 3, you see? Or 5.66 times 16 times 1, which you don't really need to do, and then divide by 3. So here's divided by 3. I get 30.16988, or to the nearest cubic inch looks like 30. Is that, are we agreed on that? Does that look right? 30. Now this is going to be inches. It's a volume, so what should I put for units? Cubed. Let's check that. All right, so that's our answer to the nearest cubic inch. Here's a cubic inch. All right, let's move on. Okay, volumes of right rectangular prisms and right rectangular pyramids. Yeah, okay. So before, the graphic before was just any kind of right prism and a right pyramid. This is the rectangular one, which honestly, we've talked about this, haven't we, right? If you have a rectangular or a square-based prism, it's the area of the bottom times the height. And this one, area of the bottom times the height divided by 3. And the area of the bottom just happens to be length times width. So this is the one that you're familiar with from when you were a little bitty baby. Right? So hardly worth the extra graphic here, but... So rectangular, let's talk about this rectangular. Did you know that a square is also a rectangle? So a rectangle has opposite sides parallel and opposite side lengths equal, which means that there's 4 90 degrees, and the opposite sides need to be equal, and the opposite sides also need to be parallel. And so that, a rectangle can be like this, where the sides and the bottom are different, right? That's what we typically call a rectangle, all 90 degrees, because opposite sides are parallel and opposite sides are equal in length too. But a square fits that definition as well. Opposite sides parallel. Okay? And this is the notation you use, the 1 arrow there, opposite, those are parallel, 2 arrows and 2 arrows, those are parallel. And they have 90 degrees. Opposite sides are equal in length. So a square is a rectangle. Every square is a rectangle, but not every rectangle is a square. Okay, so there you go. Trying to mess your brain up a little bit. But that's why they don't say anything really specific about square prisms, because squares are rectangles too. So if you say rectangular, it covers squares and rectangles technically. I know I'm saying some of this kind of fast. I know that. So if it's too fast for you and you really want me to say something again, please put up your hand. I have no problem. Remember, it's tough for me to know exactly what you're thinking. I don't know if you guys are like, okay, come on, hurry up, this is too easy. Or if you're saying, I want to cry right now, I have no idea what's going on. Like, I can't really read your minds so well. Some of you I can. Like, some of the faces like this. I know that's bad, okay? Or this one. That one's bad. This one's good. That one, I think that tells me that this is easy for you, but this one I don't know. That one I can't tell. So it helps you if you just let me know. So is anybody having a real problem right now? Like that's math related that I can help you with? I don't want to. Sorry, I don't want to hear about your lost dog right now. But do we have a math problem? Like, you're like, I have a problem. Oh, a math one? No. Okay. Sorry, I'm not a therapist. You can call me a math therapist if you want. That's weird, but I don't mind that. What did you do today? I saw my math therapist. Just made things worse. Oh, so bad. Okay, so here's another example. Can we do this example here? Let's see. Example. And yes, I do example e.g. I'm sorry. Why? Thank you for asking. Because I use x as a variable for everything, so I try not to use x anywhere else. So, example. So because I'm a math teacher, this is how I spell example. Okay? I'm just kidding. I don't spell it like that, but example. Oh, sorry, I know this is wrong. It's like this. It's example. Okay? That's how I spell example. Because I'm just a math guy. I don't do English. Actually, I've done a lot of English. I tell my high school students who are like, oh, you're just a math teacher, you don't know anything about English. I'm like, boom, automatopoeia. I do actually know a little bit of English because I've taken a lot of English classes. I've taken more English classes than all of you have because I went through university and had to take English. But anyways, I got through it. Okay, this example, e.g., determine the volume of a right rectangular pyramid with base dimensions 5.4 centimeters by 3.2 centimeters and a height of 8.1. Very good idea for you to sketch out the diagram and put this information on the diagram, okay? I would strongly suggest you do that. Even if you're terrible at drawing pyramids at this point, try to sketch it out so that you can see what's going on. So this is these are the base dimensions, and this is the overall height. I do not have slant height, and that's fine because I don't need to find surface area. I am actually looking for volume, right? So I need the dimensions, I need the height, I'm good. Easy peasy here. Volume of a pyramid is 1/3 area of the base times the height. So that's 1/3 area of the base. Because this is a rectangle, I'm going to go 5.4 times 3.2. And I'm going to multiply it by the height, which is given 8.1. That should be pretty straightforward, hey? Does that look good? Let's keep going. So, yeah, I would suggest that you divide by 3 after you multiply this stuff. Some of you might be tempted to do like 0.33 or something for the 1/3. I would caution against that. Unless you're going to put 0.33333333, like a whole bunch of 3s, then that'll be okay. But if you just do 0.3 or 0.33, that's not close enough. That's too approximate for this. So don't replace 0.3 as a decimal for 1/3. It's not close enough. So I'm going to do this 5.4 times 3.2, and I'm going to keep going because I can do all this at once, times 8.1. And you can hit equals and then divide by 3, or you can do it just divide by 3 all in the same step too. So I get 46.656. Do you guys get that? Yeah, let me just zoom out so you can see a bit more of it at once. Okay, so do you guys get this on your calculator too? All the buttons, did I hit all the buttons right? Yeah. Okay, so a couple things I need to pay attention to. I need units. So because these are all centimeters, do you see how I multiplied 3 centimeters together? So I get centimeters cubed, 3. And I also need to round to the nearest tenth. So the tenth is 1 decimal place. So, can someone just grab that door? Can you just shut that door, please? Thank you. So 46 point, what number am I going to put here, guys? 7. I got to go up to 7 because this 5 tells me this one needs to go up. Good. And then the units are? Centimeters cubed. Excellent. Let's circle that answer to indicate that this is your final answer. You're done. And I've shown my work there. I've got a diagram. This is perfect. Okay, 100% right here. Okay, that's what you want to kind of aim for. Okay, any other questions about this? Easy? Okay, just remember pyramid volume is same as a prism volume, but you got to divide by 3. Okay, the final stage of our lesson here, we are talking about volumes of cylinders and cones now. And as we found out, last lesson, or the lesson before, I think it was last lesson, but cones are the same as circular-based pyramids. Okay? Circular-based pyramids. Cylinders are circular-based prisms. Okay? Cylinders are circular-based prisms. All right, so knowing that, a volume of a cone is 1/3, same as the pyramid, times h, same as the pyramid, but the area of the base, notice, is the area of a circle. So it's still 1/3 area of the base times height, but the area of the base is very specific to a circle. It's not length times width. It's pi r squared. Okay? And so over here too, the cylinder is a right circular prism is what a cylinder is, and it's the area of the base, which is pi r squared, times h. Okay? So that's why these are all in the same section, because they're all very common. The cylinders and cones are just special because they have bases that have no sides, like a square or a triangle or an octagon or whatever. Or you could also say, did you know that you could also say that a circle has an infinite number of sides? Is that disgusting? Sorry. But the sides are so small that they're like infinitely long, infinitely small long. And so that there's like just an infinite number of points that make the circle. And you could think about each point as a side. So there's an infinite number of sides. Or you're just as good to say the circle has no sides. So that's crazy, is not? Okay, all right. A little bit of calculus there. Okay. You learned calculus today too. Cool, good for you. So circle is special, that's why. Because it could be argued it has no sides, and it could be argued it has an infinite number of small length sides. All right, let's determine the volume of this cone to the nearest cubic inch. So here is the cone. This is another example. I've sketched a cone. Remember, if you're sketching a cone, you can do like a full circle like this, and then a point up the middle, and go just two lines to each side. Better would be a half a circle in the bottom, a point up there, 2 lines. That's bad. And then like the dotted finish of the circle there, that's kind of, that's even more pro right there. Because you can't see that back edge from this perspective, right? You can just see the front edge. That's what they've done here. Okay. So 12 is the diameter, okay? So I remember from this volume formula, it's 1/3 pi r squared h. Now, this 12 is actually a diameter, isn't it? So what is r if the diameter is 12? R is 6 inches. Very good. So r is 6, h is 18. Now they're both in the same units, so that's good. So we can just use 6 and 18 for these numbers. Sometimes, you got to be careful, these aren't in different units. If this was like 18 feet and this was 12 inches, we'd have a bit of a problem, right? Which is coming. You'll have to make sure all your units are lining up. But these are the same units, so we can just use these numbers, no problem. So volume, let's see, 1/3 times pi, I'm going to use my pi button on my calculator, times 6 squared times 18. And it doesn't really matter where these brackets are, these ones here, it doesn't really matter. Actually, I guess I need to finish that. Because we're multiplying all these together, so you actually technically don't need any brackets there, you just need 1/3 times pi times 6 squared times 18. So, on the calculator, again, I would divide by 3 on the calculator, but you can do this. Here's another way you could do this. So you could use brackets, do 1 divided by 3. That's a way to show 1/3 on your calculator, if you have the bracket. And then times, we'll always use our pi button. And then times, you can do 6 squared in your head, maybe. Or you can write it like this, 6 squared. But if you can just write 36. And then times 18. So that's everything all at once. Should work. 678.58. 678.58. Did anybody else get that number? Yeah. Yes? Okay, good. Thank you. So I want units, and I want to make sure I round it appropriately. So this is going to be 678. Oh, is it going to be 8 or 9? 9. Yeah, see, this 5 makes this 8 go up, so this is going to be 6, 7, 9. And then my units are inches to the power of 3 inches cubed. Awesome. Okay, one more example, and then I'll give you your assignment. You can start working, so let's keep ripping here. Final one. Okay, a cone has a height of 4 yards, a volume of 205 cubic yards. Determine the radius. So we're not solving for volume, we're solving for one of the pieces, one of the variables inside the formula. Okay? This can get tricky to isolate this variable, but it doesn't have to be. So let me just show you what we would do here. So here's the volume. It's pi r squared times h. And then I'm going to write it like this, divided by 3. You can write 1/3 as well, but divided by 3. This may help you understand how we can solve for the radius a bit better. Okay? So I'm going to plug in all the numbers for all of the things that I'm given. So I have the volume. I'm going to plug a number in there. I have what? The height. I have the height. I'm going to plug in a value there. I don't have r. That's what I'm trying to solve for. So we're going to try and get r all by itself. So I've got 205 goes in for v. Pi is not a variable. That's a constant, but I will leave it as the pi symbol. R is unknown, so I'm going to solve for r, so I leave r as r. But I can write 4 as the height. Okay? So when you get to this point, don't freak out, but what you want to do is you want to try and get r all by itself. That's the goal. R equals, and then you're just going to have one number over here. So how do we do that? We start to kind of peel away all of the extra stuff that's multiplied by r, dividing by r, that's squaring and all that. So I need to get rid of everything. So I'm going to multiply both sides by 3. Because right now this is divided by 3, so let's get rid of the 3. I'm going to multiply both sides by 3. So my next step here is going to be, what's 205 times 3? 615. Okay, 615. Now, this is where I really want you to get into high school math, showing your work, high school math, okay? Do not piece this apart and write little calculations all over the place and try and pull them all together. Do this. Do 1 or 2 calculations at a time and then rewrite your equation. Okay? Trust me. You need to trust me on this. So I did this 3. Guess what? I'm going to write the pi there. I'm going to write the r squared there. I'm going to write the 4 there. It takes you 2.5 seconds. Okay? Now you can do kind of 2 things at once here. I need to get r by itself, so I need to get rid of this pi that's multiplied by it and the 4 that's multiplied by it. So guess what? I'm going to divide by 4 pi. I'm going to do this all at once. Okay? And yes, should you show this division? Yes. Show your work. Trust me, it'll become very quick. So now I know that pi divides out with pi, 4 divides out with 4. What I'm left with is r squared. And then this 615 over 4 pi, I'm going to do this on my calculator. So 615 divided by, be careful about brackets. If you have more than one thing multiplied together in the denominator, you should use brackets. So I'm going to say 4 pi. Okay? Because if you divide by 4 and then just write pi, it'll divide by 4 only, and then it'll multiply by pi. So that's what your calculator will do. So use brackets like that, okay? Because you want to divide by the whole thing. So this is going to be 48.94. Is that confirmed? Anybody else do that on your calculator? Yeah. Thank you. All right. Now what's the next step? I need to get r by itself. I'm so close. What's the final thing I have to undo? I have to take away is the squared. So I take the square root of both sides. Excellent. So this is how you kind of get r down to be all by itself. And then the square root of this decimal, I'm just going to do square root. I'm going to use my answer button to put the whole decimal in there to make sure this is as accurate as possible. So I have 6.9957, 6.9957, and I'm going to be rounding this anyways, so that's, yeah, so to the nearest, what does it say? to the nearest yard, okay? So we're looking for one single length dimension, so it's to the nearest yard. So 6.99 goes to 7. So R is 7. My units are yards. Okay, so check that out. Does that, everybody agree with that? Okay, so again, I don't want you to take this lightly, like showing your work, drawing a diagram, filling in all your values. If you can learn how to do this right now, trust me, you will just be flying high when it comes to calculus. You'll know how to show your work. You'll be practiced at it. It'll just go like this, like this, like this. You won't have to you won't have to worry about making mistakes because you'll have everything laid out. You'll show your work. You'll cross things out, and then you'll be able to look back and quickly double check to make sure you didn't make any mistakes. Everything is laid out. This is perfect. Okay. So if you can learn how to do this, it won't take you really hardly any extra time at all, because you'll get fast at it, and this is the way you want to do things. Okay. All right. Okay. So I think that's all I have for the lesson today. Let's go to the homework. I'll show that up. There's your assignment. You can get working on that. You got about 10 minutes, guys. 11 minutes to do that now. So please make the most of this time to work on this. If you have questions about anything, you can come up and ask me. And yeah, just remember that if you need to watch anything over again, any videos or homework stuff, you can go to the website, MathWell.com. Hey, how's it going?